Today we'll learn about the most powerful technique in programming, the dry run technique. By mastering this technique, you'll be able to fix coding errors and bugs efficiently. Without it, you are not truly a programmer. Hi everyone, welcome to STEMophile. I'm Imran Shah and this is part 2 of the dry run technique. If you haven't watched the first part, click on the I button to check it out. As beginners, you are likely facing issues like missing semicolons, typos. Don't worry, it's normal. These issues will be minimized after learning the dry run technique. So what is the dry run technique? Executing a program without using a computer is called dry run. In this technique, you just act like a computer, pick up a pen, and start executing the program line by line on a piece of paper. For example, if your program prints hello world on the screen, you write that hello world on a piece of paper. If a variable is assigned the value of 5, you write that as well on your paper. This process helps you spot errors and bugs easily. To dry run, you need to understand your program's behavior, like which line runs first and which comes next. Let's dry run the same addition program we discussed previously. Every C program starts at the main function and runs line by line from top to bottom. First, it creates integer variables a, b, and sum. Draw boxes for these variables on paper. Write their names above each box. It is the most important part of dry run. It helps us to know what value is inside which variable at a particular time. This line has finished its job. Now move to the next line. When this line executes, it will print a message on the screen, so we write that message on our paper. Enter the first number. Move to the next line. Remember, we go step by step when we dry run. This line takes input from the user via keyboard and stores that value in the variable a. Let's assume the user enters 2. Write 2 inside the variable box of a. Next line. There's nothing on this line. Blank spaces do nothing in our program. Next line. It prints a message. Let's write that message down. Next line. Again, it is a scanf. Let's assume the user enters 3. Write 3 inside the variable box. Next line. This line has two operations, addition and assignment. Dry running works step by step. So addition happens first, followed by assignment. These symbols are called operators, and we'll discuss their execution order in detail in future videos. Here, the values of a and b are added, and the result is stored in the sum variable. Write 5 in the sum variable box. Next line, the program prints the result is 5. Write this message on your paper. Next line, the program ends with return 0. We'll learn about this statement later. So we have successfully completed dry running it. When we run this program, it will generate the same result. Why dry run this simple program if we already know the result? You're right, it's a simple program, but dry running is still important to understand how it works. In complex programs with loops, conditions, or recursion, dry running becomes essential. Recursion in particular is hard to grasp without tracking variable changes step by step, which is why many students struggle. Learning this technique makes understanding programs much easier, so mastering it is crucial. There are some rules. Rule number 1. Write it down. Never dry run in your mind. Always write everything on paper, as variable values change and are hard to track mentally. Rule number 2. Don't skip steps. Skipping steps to save time is a common mistake, especially in loops. It might seem obvious, but skipping steps often lead to unexpected results. Always dry run every step. Rule number 3. Update variables. Whenever a variable's value changes, write the new value on paper. Neglecting this will result in using the old values, leading to incorrect dry run results. Remember, dry running a program is never a waste of time. Think back to the story of Mr. Hard Worker and Mr. Smart Worker from our previous video. Dry running is like sharpening your axe. Building a strong foundation now will save you time later. It helps you write efficient code and spend less time fixing issues, making it an investment in your future efficiency. Let's take another example with two variables a and b, where we want to swap their values. This means storing the value of a into b, the value of b into a, and printing the swapped values. You might think there's no need to dry run this on paper. It's simple enough to do in our mind. Assign a to b, b to a, and print the result. But when we run the program, it prints a is 3 and b is 3. Why? It should have printed a is 3 and b is 2. This shows there's a logical error. Skipping the dry run wasn't a good idea. Let's dry run step by step and find the mistake. Int a, comma b, semicolon. Create two variable boxes. A equals 2, b equals 3. The value of b goes inside the variable a, causing the old value of a, which was 2, to be lost. This is the issue. The logic is incorrect. Then the value of a goes inside the variable b, leading to an unexpected result. This is exactly why dry running is essential. It helps identify such errors. Computers are dumb machines. They do what you tell them to do. If you forget a semicolon, they'll show you an error. However, when there's a logical bug in your program, computers can't tell you that because they are not smart enough. It's your duty to correct the logic of your program. Let's correct our logic. We need a third variable for swapping the values. Temp equals A equals B equals temp. The initial value of A is stored in temp, so we won't lose it. The value of B goes inside A and the value of temp goes inside B. This is how we swap two numbers. Dry run this program step by step and let me know in the comments section. You'll make many mistakes initially, but don't worry, just follow the rules and soon you'll be dry running your programs perfectly. It requires practice. We'll learn how to dry run loops, conditional statements, functions, and other concepts when we get to those topics. Each of them behaves differently. If you enjoyed this video, hit the like button and subscribe to STEMophile. Press the bell icon to never miss an update and share this video with your friends. See you next time and happy coding.